Well, let's look at how we can calculate the pH of a buffer solution and the pH resulting from the addition of strong acid or strong base. So say I have a reaction of a weak acid and water. Now I have both the acid and its conjugate base. So and I have H3O+. H3O+, if I take the negative log of its concentration, I'll get the pH. So it's convenient to use this reaction and its equilibrium constant to consider buffer solutions, because this reaction has everything I need. It has H3O+ to get the pH, and it has the acid and its conjugate base. So I'm going to solve for H3O+. And then I'm going to take the negative log of both sides of the equation so that I get pH. So I'll take the negative log of both sides of the equation. So this left side will be pH. Negative log of H3O+ concentration is just the pH. And then I have negative log of Ka times this quotient. Now, if I have a log of a product, I can write the sum of log terms. So I can write the log of Ka plus the log of this quotient. So I have negative log Ka minus the log of HA over A minus. So negative log of Ka is pKa. So the little p stands for negative log, just an abbreviation that you'll see a lot. So this is just pKa, the negative log of Ka. And then if I invert this quotient, I change the sign of the logarithm. So this would be plus log of A minus over HA. So now I have my final equation. So I have pH equals pKa plus the log of A minus over HA. So I can find the pH of a solution, and I need the equilibrium constants of the conjugate base and its acid, and I need the Ka for that acid. So this is just rearranging the equilibrium expression. And this is called the Henderson Hasselbalch equation. However, one thing that we can do here is, if we have a buffer solution and we have about equal mixtures of A minus and HA, then we can approximate the equilibrium concentrations with the initial concentrations, because we have two reactions occurring in water. So we have the reaction of the acid and its conjugate base. We can approximate the equilibrium concentrations with the initial concentrations. So I can write initial concentrations here and not have to solve for the equilibrium concentrations. So this way, for a buffer solution, I can use the initial concentrations.